Hello, this is Algebra 1, Section 1.3, Properties of Numbers. This section seems like may seem common sense, and I say that, and I don't mean it if this is your first, if you struggle with algebra, then it's clearly not common sense. I will say this though, these properties you're about to see here, properties you'll see in geometry, properties you see in Algebra 2, properties you'll see in pre-calc trig, also stats or statistics, also calculus. Basically, these are your properties you will see for the rest of your life. That is why I say after this, and you may have already seen them before when you pre-algebra, because they are very common. They are very much your core of math. It's funny that they get lost in translations as the more math you do, but they are the properties nonetheless. So I'll just go through them real quick, what they mean. I just wrote down the property, an example, number example, and then a example of just variables. That means that they apply every time. Okay. I'll read from the book what the words are. So if you want to hear the words, you can do that. So the first one's reflexive property. That just says, for example, 4 plus 7 equals 4 plus 7. That means one side on this side equals this side. And that's all it is. So x equals x. All right. So the words they say, inequality is equal to itself. Seems kind of fair game to understand. The next one is a symmetric property. This is, for example, if 8 equals 2 plus 6, then 2 plus 6 equals 8. If you notice, I just flipped it. If this equals this, then 2 plus 6 equals 8. I just flipped the two equations because it's the same thing. We can rewrite it either way we want as long as it's the same numbers, just written differently. The general form is if x equals y, then y equals x. The wording they say, if one quantity equals the second quantity, then the second quantity equals the first. So basically the saying is they're just flipped them. If I can just flip them across equals. The transitive property, this is actually a really good one to make sure you understand and master. If 6 plus 9 equals 3 plus 12, and 3 plus 12 equals 15, then 6 plus 9 equals 15. So basically if we have this first thing, well, I know 3 plus 12 equals 15. Therefore, automatically, since 6 plus 9 equal 3 plus 12, that 6 plus 9 is going to equal straight to 15. General form, if A equals B and B equals C, then A equals C. Basically, it's eliminating that middleman. Okay, what's going on? The words for this one, it's a long one. If one quantity equals the second quantity, and the second quantity equals a third quantity, then the first quantity equals the third quantity. And that's basically what we're saying. A equals B, B equals C. Well, that means A has to equal C then, because A equals B. Okay. The last one, this one is very important from here on out, the substitution property. If n equals 11, then 4n equals 4 times 11, which equals 44. It means I just plugged in this variable of n into this equation. Give you another one. If x equals 5, then 2x equals 2 times 5, which is 10. Okay, I just plug in this number into that variable. Substitution property is huge. So you will use this a bunch, more than a bunch, like from here on out. So whenever you have a formula, basically you're using substitution property. That's all you're doing. Okay. And let's see. The book just says a quantity may be substituted for its equal in any expression. Okay, and then there's the addition properties. There's two up here. The first one is this top one. It says it's a additive identity for any number a. The sum of a and 0 is a. So that is x plus 0 equals x. That is 2 plus 0 equals 2. 0 has no value, so if I add it, boom, doesn't mean no harm. And then I have this one where it says additive inverse. A number and its opposites are additive inverses of each other. So a plus a negative x equals 0. 2 plus a negative 2 equals 0. They just cancel each other out. Okay, that's what that one basically says. The last two properties that I'm going to show is the multiplication properties. That is multiplic identity. For number A, the product of A and 1 is A. So that is y times 1 equals y. 14 times 1 equals 14. Because remember, multiplying is we're adding up, or we multiply numbers together. So 14 times 1 is just clearly 14. Moving on. The next one is the multiplicative property of 0. So y times 0 is 0. 0 is special. When we add it, it doesn't change the value. But when I multiply, it's just 0. So it cancels out that term altogether. And the last one is a multiple of inverse. So this is where I'm just going to not even explain from the book because it's confusing. Say I have x over y times y over x. That equals 1. This one might be best seen in numbers. 4 over 5 times 5 over 4. You see this one's flipped to this one. So 4 times 5 is 20. 5 times 4 is 20. Well, that equals 1. So that's basically how this multiplicative additive inverses work. There is two other properties in this section. The commutative property, that is if I could just switch how I add numbers together. And then there's the associative property, and that's how I group numbers together. Those are pretty simple and will come up more as we do more lessons. But what these ones are nice to know. I've had in my previous times teaching, I've had students still mess up with these or not understand them. And these ones they do need to understand, at least basic concepts. But out of these four, these are the big four that you will see from here on out in all your math classes for future use. What I think are the big ones are the transitive and substitution property. These are the huge ones for understanding algebra, geometry, and algebra 2. There's not many, the examples just say, hey, do the problem, name the property. I'm not going to do any examples with you guys because it will come up, but that is pretty much the notes for 1.3. So, of course, if you do need help, well, ask your teacher. If not, hopefully this can just kind of make sense to where it just kind of flows. So hopefully that helps with the notes from 1.3.